Hey, welcome back. I just wanted to do a quick review of what I've done in the last couple of days. I've kind of just gone ahead and done a little bit of the assembly on the handlebar components. So this was the one that was being worked on first, the first set of wiring harnesses, and this is it with the horn switch, with the signal switch, and with the headlight switches. I've gotten them all together. I mean, if anybody was ever interested, I'd show them how to put it together, but I think what this series is more, what I want it to be more focused on is wiring diagrams, how to navigate wiring harnesses, and how I guess put them together and organize them. So I did film a little bit of this, but then I wasn't very happy with the video, so here I am. I'll just kind of explain what I did with the left harness, and then we'll move on to the right and my plans for the next video. So on the left, again, these are just held on with 2 screws. I ended up going and putting this together so you can kind of see inside of there. I greased it all as well if you notice it's shiny, but I just kind of assembled, put all these back in, made sure to check that everything worked properly. I got the left and right signals working well. You can see that there's a spring inside of there, basically at the tip of my finger, that when you turn left to right, it will push that back, and it's a detent system that gets activated every time that you go left to right. And when you push in the middle, that's just anybody that has a bike knows that that's how you'd turn your signal off, because you don't want to just leave it on all the time. And that's just held on with those 2 screws. I'll just throw one in for now. As far as the plan for the rest of the harness, I think what I want to do is actually put some sort of like sealer in there. Honestly, I might just like throw hot glue and just kind of seal that part up, and then maybe stick some shrink tubing over top of that. This does already have a drain hole right here just in case moisture builds up, plus I threw a lot of dielectric grease in there, which is pretty useful for electronics that are going to be outdoors, especially for something like a motorcycle. So those came over here. I haven't actually pulled the connectors out of this connector yet. You can see that there's about, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 12 pins, so I'm not sure if I want to disband this and split it into 2 connectors. If I do, I might just put the signals onto one and then the rest on the other. Otherwise, this is done. So I'm just going to pretty much wait till final layup for the main harness before I decide what to do with this. If I pull up the right hand harness, I did the same thing, except this is fairly simple. Is another one of these switches. This is for the starting, and this is the emergency kill. Otherwise, it just had some quick, easy ways to feed the wires through. There's a couple of repairs that needed to be done in there. So this unit here, actually, when you press the ignition, or I guess it would engage the starter motor, it's going to send power to the fuel lines, which is actually this black and white wire. And then it also, since it's a dual throw switch, in its starter state, it will cut power to these wires, and that blue one actually right there is for the headlights. So that's why the headlights will actually turn off when you crank the engine over. Vehicles like automotive, like cars, will have similar circuits as well. And then this kind of goes to 2 different connectors. So I think that there's about 7 pins. I might actually switch these to weatherproof connectors, because as you may notice in there's no like rubber sealing or anything, and that nice bright copper bronze color is turned to gray. So we might as well put on some weather protection while we're in there. So that's pretty much it for that. Again, I'll probably take care of which connectors I want to use when I'm actually on the bike, which will be probably 2 videos from now, after I deal with what I want to do with the engine wiring diagram. The third project that I want to also tackle, as far as just kind of auxiliary electrical components, so you'll notice this is if anybody's worked on a bike, looks like a broken throttle position sensor. Now, this part in the middle is actually a 3D printed component. And I can actually take that apart. So what a potentiometer is, this one specifically was just kind of like a half disc. It had 3 prongs. One of them is just going to be power, one of them will be ground, and then the one in the middle will be attached to a dial that will wipe across. Just like if you could imagine your windscreen being a giant resistor on a car and having the wiper be some sort of blade that goes all the way across. And depending where it is on the circle as it goes around, it will show a different resistance basically. So that total resistance will be there at one end, and then it will gradually decline all the way until no resistance is there, and it will balance whatever the signal is between the full power that's been brought in or somewhere in between, all the way down to just ground being sent out. I want to 3D model a fully new case, a detachable head here, and see if I can draw up a PCB, do some research on copper tracing and how to create, basically create something that would sit inside here that would act as a variable resistor. Then I can attach some sort of spring and wiper mechanism onto that will sweep across and just be my own potentiometer. But the bike will run without this, so that will be probably something I do after everything else is put together. And here are just some more components. This was another prototype, so this is actually a potentiometer that you can just buy these off of Amazon or whatever. So as you may turn this, it will turn basically a stick that's inside of there, and there's a sweeper that's inside of this housing, the bronze housing. In the near future, my plan for the next video of this series is to take you through the wiring schematic. I know that I kind of briefly brought it up. This is a paper version, and it looks pretty awful, like, to be honest. A lot of these components here, so this would be for the rear lights section, and what I would want to do is redraw a circuit diagram that kind of makes a little bit more sense. So that at the front I get all my headlight and dash stuff. It is set like that here, but I want it to have tracings that go back and that are readable and traceable, because even the PDF version of this is just a photocopied print version because the bike is so old. Also, I'm going to be adding a USB charging cable with a fuse circuit. I'll be adding that from the battery. So here's the fuses up here. I'd actually have another line running from there. So I'd want to add that in. As well as if I change any of the connectors, I'm going to want to have a digital version so that I can quickly change something from a 2-pin connector to a 3-pin connector or vice versa. And for the mega future, I think final plans is I want to actually stick a lot of the sensor circuits on a CAN bus. Something more similar to what a vehicle would have, or just, I mean, even newer bikes. But if you've heard of OBD, and OBD2, that's an onboard diagnostics program, but it's the CAN bus, which is basically an electrical system that allows you to have 2 wires, generally, that will split off and stuff. But these 2 wires will be connected to like every bit of logic. So every computer module will have one in your car. Every sensor will be connected to it, and depending, maybe not every sensor, but depending on where you are, and depending on the precedence that each module has, the CAN bus will allow like one message over another message to be sent through, and there's just constantly this exchange of communication. But to compare that to here, this is just a lot of wires. What a CAN bus would allow us to do is stick a box, which would just basically be a computer, a standalone unit, that would be connected to all of the sensors at once. And this would actually reduce a lot more of the wiring as well. And the less wiring we have, the less diagnosis there is, the less having to pull apart. It's a lot easier to just kind of open up a box and test some capacitors and that type of stuff than it is to have to undo an entire wiring harness to find where a potential fray or short or whatever may be. So that's something to look forward to if you're interested. But as always, I apologize for the slightly longer video, but I wanted to kind of give you an update and tell you where things are going, just in case there are a few people that are interested in this type of work, electrical restorative work specifically. So leave a comment if you feel like I did something wrong, or if you have any advice, anything that I could do better. I'd greatly appreciate it.